All right, so our most common solution is solids dissolved in liquids. Gases also dissolve in liquids, and it's pretty common, in everyday life. For example, soda is an example. Any carbonated beverage has carbon dioxide gas dissolved in water. So it's a gas dissolved in a liquid. Gases and liquids kind of behave differently than solids in liquids. When solids and liquids, when you increase the temperature, you increase the solubility. It's the opposite for gases. So as temperature increases, the solubility decreases. And that's because these gases get more energy, and so they can leave the solutions a little bit easier. It's the example, that hot soda fizzes more and becomes flatter quicker, right? Because as we increase temperature, the gas becomes less soluble. This is also a big thing in biology or biological systems, such as like oxygen dissolved in water systems. So as the water gets warmer, the oxygen gas becomes less and less soluble. And if the water becomes too hot, there's actually not enough oxygen in the water for the fish to breathe, and so fish can die. So like if you can find pictures and videos online where you have like mass fish extinctions, and one of the reasons is that if the water gets too hot, they don't have enough oxygen in the water. Another thing that affects the solubility of gases in liquids is the pressure, or at least the partial pressure. So the solubility of a gas will increase with an increase in the partial pressure of that gas. Right, and the partial pressure is an important part, right? So, for example, when you have a closed soda can, the carbon dioxide stays in solution. But as soon as you open that soda can, it starts going flat. And that's because the carbon dioxide in the air above the soda will disperse into the atmospheric air, and then your partial pressure of carbon dioxide decreases, so your solubility decreases, and then CO2 leaves. But even in like a closed container, if you have some water, and then we're going to call this kind of CO2, it's in equilibrium. If you were to take this equilibrium and add, like, let's say O2 gas, like oxygen gas, the solubility of the CO2 gas does not increase, right? So more CO2 gas does not increase, does not dissolve. And that's because how much CO2 gas is dissolved is only dependent on the partial pressure of the carbon dioxide, not any other gas. Note that if you compress the entire container, you still increase the partial pressure of the carbon dioxide gas. So, squeezing the bottle will increase the solubility of carbon dioxide gas, but adding some other gas won't. Or the other thing you could do is you could add more CO2 gas. Right. And then if you do that, that will increase the solubility of the CO2 gas because you've increased the partial pressure. So overall, with gases and liquids, as you increase the temperature, solubility goes down. As you increase the partial pressure, solubility goes up.